This is day 67 of Daily LeetCode. Daily LeetCode. We are back once again. Today we're going to be working on a problem that Thomas mentioned in a comment. It's called LC151, called reverse words in a string. So Thomas mentioned this one, and it sounds, gave it a quick read. It does sound like it's a two-pointer based problem, so we're going to try that. So yeah, also doing a slightly shorter session today. So yeah, we're just going to jump into it. So 30 minutes. Given an input string S, reverse the order of the words. A word is defined as a sequence of non-space characters. The words in S will be separated by at least one space. Return a string of the words in reverse order concatenated by a single space. That S may contain leading or trailing spaces or multiple spaces between words. The return string should only have a single space separating the words. Do not include. Note that S may contain. The return string should only have a single space separating the words. Do not include any extra spaces. Let's map this to our example. Given input string S, reverse the order of the words. So given the sky is blue, it's our input string. We're supposed to return blue, the sky. Blue is sky, the. Okay, and given hello world, we should return world hello. Your reversed string should not contain leading or trailing spaces. So a good example should return example good A. A string will always have at least one character, and S contains English letters, uppercase and lowercase digits, and spaces. There's at least one word in S. Interesting. So I think maybe a naive solution, right, would be to iterate over the string in reverse, and as soon as we find a character that exists, right, then we're going to just start writing that character to our string, so EULB, right, and once we find a space, we'll add it, and then we'll keep iterating until we find a character, and then we'll push. I guess that's the thing. They want us to keep the word in reverse, so we actually don't want EULB. We still want blue. So maybe if we change the angle, maybe we could do something else. What if we use 2 pointers to iterate through the string in linear going forward? So we'll start with the first pointer, which will try to find the first character, the first non-space character. Then we'll have a second pointer, which tries to find the next the character right before the next space, right? And then what we'll do is we'll add that character to the output string in a stack. And then we could just pop it off the stack in reverse to get what we're looking for. Separate them by spaces. That'll take linear time as well as linear space. And is the number of words in the string. Sky is blue. I think Thomas mentioned no split or anything like in both string splits and etc. So he makes a good point here. If we 2-pointer this, we could have this. Okay, so if we 2-pointer this, right, so we could do 2-pointer over S, right? And then we want to, since we're gonna have to, I guess we're gonna have 3 pointers, right? Because how do we know when we're done? I guess you could say when left and right are both greater than s dot length, right? Then we'll know we've gotten to the end. Say while left or right is less than s dot length, right? What's gonna happen is, right, we're gonna have a while loop to find the first non-space character, right? And then we'll have another while loop to find, starting from this T, the first space character, and then going to the index right behind it. Then we'll add that to a stack that we will push in reverse. And we can pop elements off of to get the output that we're looking for. So we'll have a stack, right? Then we'll have 2 while loop. I guess we should have better scaffolding, a better pseudocode here. Basically, you want to say is that find next non-space index, and then find next space character, but there can be multiple spaces, right? So we don't, yeah, so we'd like to find the first space, so find next space, character index -1, right? Then we can iterate over left to right, create word, push on stack, and then afterwards we can elements off stack and add with space. Let's see if that makes sense. So if we take our first input s, so left and right are both going to be equal to 0, and both going to be less than probably the length of the string, which is like 15. I'm going to find the next non-space index, which is 0, right? And then starting from 0, find the next space character, which would be here, index 4, -1 would be index 3, iterate over with 0, 1, 2, create word, push on stack, right? And then afterwards, what would we like to do? Right, we probably want to set left equal to right +1. So obviously left equal to right +1 will be at the space, which is perfect, and we'll find s, right? Which is actually fine because right gets set to start at wherever s is and then find the next space, next non-space character. So we set this equal to 4. These are both still less than s dot length. Then we want to find the next non-space index starting from 4, so it would be s. The next space character starting from this, which would be this space, go y, sky, and so that would work. Let's see, for this one, if we start at 0, find next non-space, start at h. And I think this version, because we're not, we could fuse this, iterate over the word into this find next spot right here to get linear time, but I think in this case it's actually going to be n squared in the worst case. Let's try this implementation. So stack's going to be empty. We're going to have left equals 0. Let right equal 0. And we'll say while left is less than s dot length, for right is less than s dot length. We want to find the next non-space index. So when we do that, we'd say while left equals space right left plus equal 1. Right. Fortunately, this is going to start at t, so we don't have to do left equal. We're not actually going to do anything here. Then you want to find the next space character, right, starting at left. So we can say right equals left, and then find the next space character. We'll say, well, not left, but s sub left, right, and s sub right equal while it does not equal space, do right plus equal 1, right? And then as soon as we'll find the next space, so as soon as we find the space character, we'll stop. It should be here. I want to make sure that this is less than the length, right? S right is less than s dot length. And then over here we can iterate over left to right. Right, so we can say constant word, or we'll just say that word equal this empty string, and we can iterate over left. So we'll say for let I equals left, and while I is less than or equal to right I plus plus, which should give us exactly what we're looking for, I think, right? Because if right is going to be equal to this fourth index here, then we're going to want to go up to 3 excluding 4. So do 0, 1, 2, right, and 3 would not be less than 0, 1, 2, 3. 3 would not be less than 3. So we want to create the word. Do that, we do word plus equal s sub I. To build the word, then we want to push it onto the stack. And then we want to set left equal to right plus equal 1, right, because right would be here. Right, so maybe we don't even need to do plus 1. We can just set it equal to right. So I just want to print the stack to see if this makes sense so far. And then we'll just return an empty string to start. So it actually doesn't look bad to start. So we could just have our output string look like this, and then we'll just say for const we'll say while stack length does not equal 0. We can just make this an array, or make it a string. And then we can just do output dot push stack dot pop, and then maybe we could return output. We want to separate them with a space. So we can actually do it like this. We'll say if stack dot length equals 1, right? Then we actually want our string to be stack dot pop by itself with no space. Otherwise, we'd like it to be stack dot pop, but with a single space. We can do output plus equal text. So let's try it for more complicated input. Oh, we still push even if the word is empty. So we'll say if word.length is not equal 0, right? Then we'll push it onto the stack. Right, and then we'll try a good example here. Okay, so I think this version we have is n squared, right? Since we pretty much calculate this, we're iterating over the length of the string, right? But it's possible, right, that we do, we find this subset, right, this range that we're looking for, like right, then we iterate over this range, right, even though we already iterated over it. So we end up duplicating a lot of operations. So I think we can fuse this right portion right here and building the word into one. Say right equals left, and we'll say word plus equal s sub right. That way we don't have to build the string here. So this gives us the same exact speed. So it looks like there is an in-place solution, right? If your string, the string data type is mutable in your language, can you solve it with constant extra space, right? Actually, our strings, I'm getting the vibe, it seems that the string primitive is immutable. But it's also sort of mutable, because when you add a value to a string, you're actually, I think, you're just creating a new string, I think, with the character added. This version, I think, would be linear time. Linear time with linear space. Linear time with linear space. Can we do better than that? If the string data type is mutable in your language, I'm pretty sure, let me see. We can just test it, right? We'll just say const s equals 1, 2, 3. And then we'll say s sub 0 equals a. And we should get, index signature and type string only permits reading. So what if we did something like this? We used a string object. But I think that's explicitly different. string data type is not mutable, but we could pretend it's mutable if we just spread s into an array of strings, into an array of characters. So if we did that, could we do, let's see, we have B, BLUE, we'd like to get blue here, is here, sky here. What if we swap the positions of the characters so that if we had the sky is blue, if we had something like this, if the sky is blue, what if we did, we find our first character which is our first word which is blue, right? Maybe we iterate from the reverse, we find our first character which is blue, and we find our first word from the front. We would swap them to get something like this. Blue guy is What if it's an array? These values wouldn't move, so it'd really be something like this. You know what, maybe we could take optimization even further. Instead of pushing it onto a stack that we have to read again, what if we just, if we had output, we declared it further up here, and then what we could do is we could build a word, if the word's length wasn't equal to 0, right, instead of doing stack.pushWord, we would just say output.pushWord. Not push, but output plus equal word with a space after it. We could return as output.trim. Right, we're still going forward. So in this example, maybe we have to go backwards. So I think everything still stays the same. You can keep left, except we'll say while left is greater than or equal to 0. We'll say the same thing for right. While right is greater than or equal to 0, right? We'll make both these equal to s.length minus 1 to start. We'll say while left is greater than equal to 0, s sub left equals space, then left minus equal 1. The same here. So you do right minus equal 1. left is greater than or equal to 0, or right is greater than or equal to 0, while left is greater than or equal to 0, and s sub left. So we actually don't. Oh, right, but now our thing is actually in reverse. So when we go left E, right, we'll go to right, we'll find this space. It should technically be n squared. If we iterate over E going to E, we had LP max. We have what we're looking for, our just letters are in reverse. So this could work if we could do this in constant space. We reverse, maybe it wouldn't be constant space. You need to store this. You're reversing the string. I guess you could reverse the string in place. So what if that is what we did? Could reverse the string first. So what if we said that R is equal to, we spread the string into S, right? Then we could have let left equal 0, let right equal s dot length minus 1. And then you could say, while left is less than right, we could say R const temp is equal to R sub left. R sub left equals R sub right, and then R sub right equals temp. Then we can do left plus equal 1, right minus equal 1. That way the array would now be reversed. We still get the wrong answer, but we could change all the S's to R's. We'll have to, we're gonna have to think a bit more about how to do this. We have a linear time, linear space version, and we're gonna have to think a bit more about how to turn this into a linear time constant space. But I think we can definitely figure this one out. But I was really way too close to the camera. But yes, that was the wrap up day 67. We'll probably do a longer session when the days get a bit closer. But yes,